Welcome back, dear students. In today's session we are going to do two important theorems of circles, that is theorem 10.8 and 10.9. So before we go for these theorems, let's recollect few basic things which will help you to solve and understand these theorems easily. So we all have learned in triangles chapter about the exterior angle property of a triangle. What is exterior angle property of a triangle? In any triangle, if one side is extended, okay, if any one side of a triangle is extended to form an exterior angle, this exterior angle will be equals to sum of interior opposite angles. Okay, we learned this in triangles chapter. We learned that angle x is equals to y plus z. Yeah, this was the exterior angle property. X is equals to y plus z. So this property is used in solving theorem 10.8. Another property of isosceles triangle we learned in triangles chapter, that is, if two sides of a triangle are equal, then the angles opposite to these equal sides are also equal. Okay, so if in this triangle ABC, if AB is equals to AC, then we can say that angle B is equals to angle C. So this property also we learned in triangles. We are going to use these concepts in solving theorem number 10.8. So what is theorem 10.8? Let's discuss it short. Theorem 10.8, according to this theorem, if in a circle, okay, if this is an arc, if you take this arc, the minor arc or major arc, the angle made by this arc, okay, say AB, if this arc, minor arc AB is making an angle of some measure like this at center, this angle will always be double of the angle made by the same arc in the remaining part of the circle. Okay, so this theorem says that we have to prove that this angle AOB is double of APB. Okay, angle AOB will always be double of angle APB. This is our theorem 10.8. So we'll see how to prove this theorem. So we'll quickly see with the values. If this angle is say 30 degrees, then this angle has to be double of this, so this will be 60 degrees. Okay, or if this is 100 degrees, then this has to be half of this, that is 50 degrees. So this is theorem 10.8. let's quickly go to the theorem now. So the theorem says that the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. So angle subtended by an arc at the center, okay, at the center is double the angle subtended by this arc. This is the arc here. Okay, this is the arc. Angle subtended by this arc at the center is double the angle subtended by it in the remaining part of the circle. So let's start doing theorem now. So we'll consider, because the statement is given, figure is not given here, so we'll take our own figure. So we'll consider a circle with center O. You can see a circle with center O, arc PQ. Okay, can you see the arc PQ here? This arc PQ of this circle subtends angle POQ at the center and PAQ at a point in the remaining part of the circle. Okay, so PAQ is the angle made by this arc PQ in the remaining part of the circle. So we need to prove that these PAQ, this POQ, this angle is double of PAQ. Okay, so let's see how we can prove this. For this we'll write a construction step, that is join AO. We'll join A to O and extend it to B. Okay, we'll join A to O and extend it to B. So now you can see there are two triangles formed here, POA, and another triangle is QOA. Okay, QOA. These are the two triangles. Now I can say these two triangles are isosceles triangles. Okay, this is not required, KS1, all those. These two triangles are isosceles triangle. In triangle APO, you can see in triangle APO, I can say OP is equals to OA. Why? Because these are radii. Okay, radii of a circle, whatever number of radii you draw, all the radii of a circle are equal. So I can say OA is equals to OP. And when this OA and OP are equal, I said you the isosceles triangle property that opposite angles will be equal. Okay, angles opposite to equal sides. So when these two sides are equal, I can say these angles are equal or not. These two angles are equal. Okay, that is OPA is equals to OAP. Similarly, now I'll apply exterior angle property for this triangle. You can see for this triangle, I said you exterior angle property. Exterior angle is this one. Yeah, this is exterior angle, POB or BOP. BOP will be equals to, I said you the exterior angle property. Exterior angle is equal to sum of interior opposite angles. So BOP is equals to angle OAP, this angle and this angle. Okay, this will be sum of these two angles. So angle OPA and OAP. But you can see that in place of OAP, in place of this OPA, I need to prove this angle. Okay, I need to prove POQ. I need POQ. So POQ and this part I need. Okay, so to get this part, I'll keep PAO angle. Which angle I'll keep? PAO, or you can say AOP. I'll keep this angle safe with me. I'll replace this angle with the other one. So you can see here OPA plus OAP. Okay, so in place of OPA, in place of this OPA, I can write OAP because these both are equal. Okay, OPA and OAP are equal. So in place of OPA, we are writing OAP. So OAP plus OAP, that is 2 times of OAP. Same thing we do for the other triangle here, that is the triangle AQO, and we get equation number 4 here, BOQ. I'll take the exterior angle for this one, and I get BOQ is equals to twice of OAQ. Okay, so we have got 2 equations, equation 3 and 4. Now I'll add this both the equations. Okay, I'll add equation 3 and 4. So BOP plus BOQ, you can see the left hand sides. I'm adding left hand sides first. BOP plus BOQ is equals to twice of OAP plus twice of OAQ. Okay, so I have got what is required to prove. So BOP plus POQ, so taking 2 common from here, taking 2 common, I'll get twice of OAP plus OAQ. BOP plus BOQ is how much? BOP plus BOQ. Together you can write it as POQ. Okay, and OAP plus OAQ, OAP plus OAQ, you can write as PAQ. Yeah, so finally we get POQ is twice of POQ. POQ is twice of PAQ. So we can use this theorem in any problem where it is applicable. Okay, this is one of the most important theorem in this chapter. Using this theorem we can solve different questions. Okay, so let's quickly see one question. If angle made by this arc, say this arc is making an angle of some measurement at the center, say this is 90 degrees, then how much will be the angle made in the remaining part by this theorem? This angle will be half of this angle, so this will be 45. Okay, So you can solve many MCQs by using this concept. If the angle made by, if suppose let's take one more circle, if the angle made by the arc is 180 degrees, okay, if it is 180 degrees like a semicircle, okay, if this is 180 degrees, this is the diameter, what is the angle made by this arc in the remaining part by this theorem? This has to be 90 degrees or not? Yes. So that angle has to be half of 180, that is 90 degrees. So this is also one theorem in our chapter, that is angle in a semicircle is right angle. What do you say for this? This theorem is read as angle in a semicircle is a right angle. Okay, in a semicircle whenever you make an angle, it will always be a right angle, that is 90 degrees. So this theorem is given here. You can easily prove this theorem by looking at the steps. Okay, so try this theorem, angle in a semicircle is a right angle.